Alright, now we're going to put this all together. We have a roller coaster example here, where we start off at 0 meters per second and the kilograms of our cart is equal to 10. We are going to assume that the acceleration due to gravity that we are using is equal to 10 meters per second instead of 9.81. We start off at position 1, 5 meters above the ground. Then, the cart accelerates up a hill, neglecting friction, to 20 meters per second in 5 seconds. At position 2, the height is 10 meters above the ground. As we go from 2 to 3, we are going back down the hill, but here friction is applied in 10 seconds. At 3, the velocity of the cart is 20 meters per second still, but the height is equal to 0. Then we are lifting the cart up to position 4. The height is equal to 7 meters in 5 seconds, and the cart is lifted now with a velocity of 1 meter per second. Finally, the cart will come down and reach the spring at position 5. Here at position 5, the height is equal to 3 meters, and we are given K is equal to 3. So, to start off with, how would we find the potential energy at position 1? Well, we know potential energy is equal to mass times gravity times the height. We are given that the height is 5, the mass is 10, and we're using acceleration due to gravity is 10 as well. So therefore, that's equal to 500 joules. Now, what would be the kinetic energy at position 1? Well, at position 1, we have 0 meters per second, which is the velocity. So in order to find kinetic energy, 1/2 mass velocity squared, we're not going to be able to do that. Therefore, it's equal to 0 joules. To find the potential energy of the spring, we don't have a spring at this exact position. Therefore, we have no potential energy of the spring. Internal energy Q is equal to 0. Work is equal to 0. And power is equal to 0 as we don't have time or work. The height above the ground we are given is 5 meters. Next, let's look at position 2. Here the cart will accelerate to 20 meters per second in 5 seconds up a hill, neglecting friction to get to point 2, where the height is now 10 meters per second, 10 meters. So potential energy equals mass times the acceleration due to gravity times height, 10 times 10 times 10, it's equal to 1,000. Kinetic energy, 1/2 mv squared. Well, we are given now that it's 20 meters per second for velocity. 1/2 times 10 times 20 squared, and we know that kinetic energy is equal to 2,000 joules. Velocity, we just said, is 20 meters per second. We have no spring, so therefore no potential energy, no internal energy. Now, work we do have. Here we had 500 joules, and here we have 3,000 joules. The difference between this, which is the work, is equal to 2,500. Now, to find power, it's work divided by time. We were given 5 seconds. So 2,500 divided by 5, power is equal to 500. And power, again, is measured in watts. And the height we were given is equal to 10 meters. Now, let's move on to position 3. From 2 to 3, we are going downhill. Friction is applied, and the time is going to be 10 seconds. We are still at 20 meters per second for velocity at a height of 0. So, in order to find potential energy, mass times acceleration due to gravity times height, we have no height, so therefore it's 0. Kinetic energy, we're still going to use 1/2 mv squared, and it's still going to be equal to 2,000 joules. Velocity is still at 20 meters per second. Potential energy of the spring we do not have. Internal energy, since we do have friction, is going to be the difference, again, in the kinetic energy, potential energy, and the kinetic energy here. 2,000 plus 1,000 is 3,000. Here we have 2,000. Therefore, 3,000 minus 2,000, 100. 1,000, my bad, 1,000. The work is equal to negative 1,000, opposite internal energy. And the power, work divided by time, which we are given 10 seconds, is equal to 100 watts. Again, our height is equal to 0 meters. Alright, so now let's move on to position 4 and 5. So at position 4, from 3 to 4, we are lifting up to a height of 7 in 5 seconds over a velocity of 1 meter per second. So how would we find potential energy? Again, mass times acceleration due to gravity times height, we now have potential energy of 700 joules. Kinetic energy, 1/2 mv squared, where velocity is equal to 1 meter per second, is going to be 5 joules. Velocity, again, we just said 1 meter per second. Potential energy of the spring, we still don't have a spring. Internal energy is going to be equal to 0. Our work is going to be the difference, which is 700 joules here, and the 5 joules here, so 705, from the 2,000 we had in the past problem, so 2,000 minus 705. 1,295. Power, work divided by time. We were given a time of 5 seconds. Will give us 259 watts. And the height, we said, is equal to 7 meters. Now, last position at position 5, the cart will be going back downhill and stopping at the spring. Here we are given at the spring K is equal to 3. And the height is equal to 3 meters. So how do we find potential energy? Again, mass times acceleration due to gravity times height. We have 10 times the height of 3, 300. We're given no velocity, and here the cart is stopped by the spring, so that's equal to 0 joules. The velocity, we just said, is 0. The potential energy of the spring, which we can find this equation in our reference table, 1/2 kx squared, or we can get it from the loss here, 300, from the 705 here, to know that 705 minus 300 is equal to 405 for potential energy of the spring. Internal energy Q is equal to 0. Work is equal to 0. Therefore, power is equal to 0 watts. And we said the height is equal to 3 meters. So, using this roller coaster example, we are able to tie in work, power, force, and energy, all from this unit, to calculate all different types of things when a cart is moving in various directions and over different speeds.